Hi again. So this is my task two. Benchmark pruning built inside the evolve scope. So the README file pins the exact evolve scope commit that I developed against. So let's look into the problem, which says a customer wants to know if a model is good enough at coding and also the long context reasoning. Running the full benchmark on every candidate is slow and expensive, so I shrink each benchmark to a small sample that still gives the same answer. So here, the core idea is a balanced mix. I score every question by the difficulty level and how often the reference models miss it. Then I split questions into difficulty bands, and then keep a small slice of that from each band in the same proportions as the as it creates a full set in a sampled version. So the short version mirrors the full version, and its score tracks the full score. So it's deliberately not a random sample, not just the easy or the hard ones, or just not just handpicked. Those are like forbidden ones. So and the difficulty comes only from the reference models. So never the model I am testing. So it still works for a new models that I haven't seen. So let's look at the adapter. And yeah, let's look at the adapter. And this is the key design decision. One universal adapter, it takes any registered benchmarks and wraps it with the real adapter and register a prune twin. That's why the live code bench or the AALCR or the MMMU all get pruned versions from the same code, and a fourth benchmark can also be done in one line. So the clarification email specifically asked for this, and that's why I'm making more stress on this. And the universal adapter is not hard coded. That's exactly how it built. And let's look at the commands, how it works. So here is the proof that it needs no model to run, and it leaves one model out. I hide one model, build the short test using the other two, then predict the hidden models and give the real score form on that, and graded by the LLM as a judge. So it's not noiser. There I care more about keeping the ranking of the models, which the compare runs tool reports. And part B is a working code. It's not just a design thing. So here the real risk is with the multimodal, which isn't whether the model is smart or not. So it's that the image encoder can quietly degrade after compression. So it looks fine on the test, but it goes half blind on charts or any kind of visual images. So my probe picks the images you actually have to look, and measures the score with the image minus the score of the text. So a healthy encoder shows a big gap. A degraded one shows almost none. Random sampling cannot catch these kind of things exactly, because a lot of MMMU is answerable for the text alone. So these are the answers that were stressed in the task, the handout A and the handout B, which I wrote in .md files, and also submitting uh, in the Git repos. I also gave permissions to the remaining three reviewers uh, as a collaborator access. So handout A is the technical write-up with these numbers. Handout B is for the customer team, and how a sales engineer runs one command to get a go no go answers over here. And one honest note is that a full live run needs a model API endpoint. So my reproducible proof runs offline on the ship data, but I confirm the pruner wires it into a real evolve scope end to end. So yeah, that's my task too. And thanks for the time again. Yeah, thank you.